So, OBS is having a laugh today. Um, I'm using this open broadcasting system software studio, open broadcasting studio. But this thing's having a laugh today. Like whenever I hit record, it just randomly crashes, or it's causing my machine to have like weird issues, or whatever. I was fiddling around with microphone settings, so I'm assuming it's something that I did on Windows that's causing an issue. Um, Not a big deal. Not a big deal at all. I just want to hear myself a bit better. I've got audio mix, what's it called? Stereo mix, or listen to this device switched on in the audio settings somewhere. So, last time we got to this point, we have a bouncing ball thing on the screen and we can bounce on the paddle. Okay, so what do we need to discuss? We need to discuss something called the core game loop. A game loop, contrary to, well, from a software development perspective, a game loop is like gather inputs, update entities, and then render. Right? That's it. That's your game loop. That's your entire thing. But from a game design point of view, your game loop or your core game mechanic is what are players going to do when they interact with your game, right? What do you want to define as the primary method of interaction with your software or your game or your world? How can I explain that a little bit better? Okay, let's look at the simplest game, Snake. The Snake game is a resource gathering game. So the core game mechanic there is go and find resources, acquire those resources. That's it. That's the whole thing. So there's nothing really that special. It's not really the same with this game. This game that we're building is more of a go and conquer the blocks thing. So the core game loop would be send out your block thing to go and attack the enemy block things, right? That your method of control is I have a paddle that I can use to kind of keep this block thing from going on my side where it shouldn't be. You obviously get more involved game loops. Like one of my favorite games I love to talk about is Minecraft. Minecraft is a gather resources, explore, set up camp, and you can either then live at that camp, build a city, or do whatever. But the main aim of the game is go explore and gather resources. But that game loop is so bespoke that you have the system of crafting that was integrated like way in the beginning. So you can then take those resources and convert them to something else in the environment that actually helps you um, move forward, kind of progress in the game. But then these guys decided, Mojang Studios said, like, look here, we're gonna let you craft like simple tools and things, but we're gonna turn this up to 11. You can actually craft computers and like transportation systems in that game. It's insane now, and it's amazing. It's got a multiplayer component, so you can do a whole bunch of stuff. But for what we're building here, just as a first exploration into what kind of thing can you do with JS, I think just putting a block on the screen and trying to hit it with this other block is it's good enough. Um, I thought of a couple of things that might make it really cool when we get to like the advanced series, but for now I want to just do like bounce on the paddle and change direction. So the next step is we need a bunch of other blocks on the screen. So one of the interesting things about this graphics context thing is that you have the ability to save the state of the context, right? So we can say save and then draw a bunch of blocks and then restore. And I think that's gonna help us a lot. So we can go Google how that context thing works before we touch any more code. We'll just make sure that my assumption is correct. So JavaScript canvas context save, if that's even English. Yep. Save pushes the current state onto the stack. Restore pops the state on the stack, restoring the context to that state. Let's see what Stack Overflow says. As much as people complain about this, this is an amazing site. So you change a bunch of styles and do a bunch of stuff, and then you save all these properties. And then you rotate, scale, translate, change fill styles, clear X, stroke, and then restore. Huh. That is exactly what I want. That's the thing, right? So yeah, we draw. If we don't have a context return, we update the ball, we clear this just changes the position of things on the screen, and then it does player.draw, ball.draw. So we can do ctx.save and then ctx.restore. I guess the big question is, do we want to draw, we should draw the playing field first, and then the player, and then the ball. I think that gives us a Z index. I don't know if you guys are familiar with the Z index of drawing, or if anyone's ever heard of the painter's algorithm, but the way that should work is, let's say this is a flat piece of paper, you're looking at it from the top down, right? So the first thing you draw on it is like a green shape. Let's just say you're using really thick ink, and then you draw this red shape on top of it, right? So this is the top view. So what you would get if you looked at this from the front is you'd get this piece of paper with this green shape on top of it, and then this red shape on top of that, right? So if you were to go and fill this in, oh shoot, full solid color. So if you were to represent that in this, so I chose solid color. Are you kidding me? Why does that not work? Outlines. Oh, derp. So this would be. Oh, color do you choose? Okay. So you get this thing, and then you have this green on top of it, right? So that's the second or the first thing you draw, and then the next time you come in and draw something, it's red, and that's what you get. So this is how we're going to order it. So I want to draw the playing field, so all the gray thing has all the playing field on it, and then the green thing would represent the player, I guess, the paddle, and the red thing would represent the ball. So when things overlap on screen, the ball is always visible, and I think that's something important. So we would draw the ball last. So yeah, we draw the ball last. So we'd have to do context save and restore before we do anything else, right? And after we've saved the context, we'll make a bunch of context switches. So playing field dot draw and context restore. That gives us a working playing field. So now we need to define what a playing field is. I want the playing field to be a collection of rectangles. It's just going to be like I want to say a 2D array, but it could just be a flat array to simplify everything. So it would be an array of X amount of rectangles. So I'm just thinking what would be the easiest way to represent it. So you could have a thing that's a playing field that could be a collection. It will have a collection of rectangles inside. We don't really need an x and a y and a width and a height. We have a width and a height. Screw it. Screw it. We'll just do this. So far for like nice refactoring. So get playing field, get battlefield, get area. Okay, so I assume it's gonna be playing field function xy with height. That's xy with height. I want a rectangle size. RSW RSH. So rectangle size width. So this dot rect width equal. Why would I put it easing? I know it's rectangle size width and rectangle size height, but that doesn't make sense. RW and RH is fine. So this dot rect h equal RH. So here's the fun part. We do a calculation. Our playing field should cover the area defined by these bounds, right? And I want it to be like the top third of the screen, I think would be useful. So when we define this, it should just be the top third of the screen. So x, y with height. Varnum rect x equals this dot width divided by rectangle. Why would I just use width? Right? It's less typing. And then varnum rect y equals height divided by rectangle height. Do we want it to be gaps between them? I suppose so. Okay, whatever. Let's first do it and then tweak it, right? So you now have a list of numrect x and numrect y. So actually, why not just store this, right? So this dot and this. Well, this dot rect equals playing. Okay, let's just do this so I don't confuse myself. X equals new array. You can actually do this, right? For actually, let's just do chain k. J equals 0, j is less than this dot numrect y, j plus. Oh, what have I done? Busted up something. So last video you would have remembered that I had to change my shortcut settings for this editor because I kept hitting, I think it was F11 by mistake when I tried to backspace, and then it would go into full screen and not want to come back out. So that was a fun adventure. For k equals 0, k is less than this. I think the code speaks for itself, so I don't have to repeat what you're seeing here. So we can say this dot rect, that's it, dot push, and then it's an object that goes in there. So what I want is let me just think about this logic. So you put a rectangle in, and its position is, its x position is it has, oh, can't I just do new rect? It's the wrong rect. And then pass in xy with that. So the x is k times rectangle width, right? The y is j times rectangle height, and the width is rectangle width and the height is rectangle height. There you go. Got a bunch of rectangles. Great. So now these things live on the screen. I want these things to have a color. I suppose we can fiddle with the color when we draw. There's nothing special about it. So we have a bunch of rectangles, and then playing field dot prototype dot draw. I think just requires this. Oh, here's something interesting. For while I equals 0, I listen just a bit start plus. The draw function doesn't need a nested loop. We've already determined where these things go on the screen, so we know exactly what's up. So we can just do this. This directs I x. Yeah, this is just going to be direct I dot everything. So I want to change the color of these things. What would that be? I want this to have. Where did we even set? Ah, there we go. So I want to stroke this rectangle in. The fill style would be. What is red and green? It would be whatever that is, and then stroke style would be just black, I guess. Let's see what that does. Shoot. What is this? Okay, so error 1, right? I must have busted up something really good when I started. So invalid or unexpected token somewhere. We won't tell you where. It will just be somewhere. Ah, there we go. This, oh, there. Not a semicolon. How inattentive of me. Well, no errors this time. Well, I think. Oh, no, there's an error. Console. Invalid or unexpected token. How is that an invalid or unexpected token? Console. Oh, CT is not defined in draw 122. Let's go see draw 122. Is that it? Is that how you're gonna play me? Playing field is not okay. Great. So now we're getting somewhere. We can now define the playing field. So we can say var playing field equals new playing field, and then the x is, I don't know, 10, the y is 10, the width is, width, and the height is, it's actually the width is inner width minus 20. It's weird. Oh, sorry about that. My microphone is balanced precariously on my desk, like You won't even believe what I did. I cut a piece of like foam and then stacked the microwave up like Jenga. So there's something I want to do, something that's been bugging me for a while. I want to not hear what I'm saying when I say it, because now there's like this extra mental processing thing that it does. Let me just fix this. No, I don't know how to fix it. I can't find the buttons. Um, I'll just leave it like that. That's fine. So we've got rectangles on the screen. So we've got width and height. Height is divided. Oh, actually, I want 1/3. Just divided by 3, right? And then the rectangle width is like 20 and the height is 10. I don't know. We'll see how that looks. Say 5, that. So the first thing we can see is that it looks like garbage. How do you stroke and fill a rectangle? Like, okay, let's not get distracted. The first thing we can see is that that subtraction isn't really necessary. So let's just see. So minus 20 would have. Where's the left edge? Huh. Oh, I know what this is. I know what this is. I know exactly what this is. I didn't actually take any of that into account when I started doing this. So the playing field doesn't actually require a width and a height, right? Like, there's no reason to store that. So you don't actually need the X and the Y because we're not using it. So you just need, in fact, we can simplify this and just use inner width and inner height directly. Well, kind of. Let's just pass in the width and the height. So we don't need the X and the Y. We don't need to do a funny subtraction for width. We'll do the calculation for inner height, and then the width and the height is 20 and the height is 10. So inside playing field where we draw this, how do you do a rectangle that is both filled and stroked? Rect. Is that it? It fills and strokes the rectangle. You've got to be joking me. The canvas is a state machine. Begin a path that creates a state, and then you do a bunch of stuff, and then you stroke that, and then you begin a path which recreates a state. I don't like it, but it's the tech we chose. I literally said, hey, I want to do this, and then when I did the eeny, meeny, miny, mo thing for like a language, I said, JavaScript. The rendering engine's built for us. It's just a browser. So I guess I don't like it. Okay, whatever. I think the easy thing is if we just change this value on the fly. So we don't need to keep out the stroke style. We're not stroking a rectangle. We're not stroking anything. So let's do let's do a funny calculation. Let's be weird about it. So we set the fill style. We don't care about alpha. Let's just do RGB. So the RGB is gonna be. Does JavaScript have like template literals? Can you do this? Right? How does that work? $C dollar. It's R. It's R. G. I'm not having a stroke. I'm just looking for the dollar symbol on my keyboard. B. So yeah. For RGB, right? R equals. I suppose it's 255 minus inner width divided by this dot vector x plus 1. So we don't get the division by 0. Inner width divided by the x position is divided by bigger and bigger things, right? So division by 10 would give you something. Okay, so then you just do math.round in like English. So there's an open bracket. Let's just check. Okay, great. So math.round G is just gonna be in height divided by this thing that y plus 1. Then B is just gonna be like some constant B equals, I don't know, I can go to like, I don't know, whatever, doesn't matter. We can do math.max oh no, min of I and 255. That'll fix it. So then we do full style and then full red. So let's save that and go see if JavaScript actually supports the template literals that I was thinking about. Busted something. What did I do? Oh yeah, silly me. I can literally see the thing on the screen. I still type it wrong. So this same story. Yeah. Does it really support this template literal thing? I don't know. Yeah, it does, but it's not great. Okay, first let's think about it. Oh, yeah. So 255 minus inner width is like 320 divided by the x is 10, then 20, then 30, then 40, then 50. Can't I just do this x 255? Doesn't that work? Let's see what the x dimension looks like. Oh, that's pretty. So what does it top out at? 320, right? Which actually then tops out to 255. So let's just do x divided by 2, 128 plus x 4. Okay, there's my calculation. I like this calculation because this can just be 92 plus this, that's y. And then b is just math min I, etc. So let's go look at better spreads. I really felt like it. The b, well, the x. Okay, let's do this. I just want to find this thing. So this can just be divided by 1. I like that. That can be divided by 2, and this 32 by 4. Okay, so that's fine. That's fine. I don't care too much about the color. I just care that you can see there's some difference between them. So the red, how about we do, so we can do something like determining the y of this rectangle. Actually, it's just I just need the colors to spread out a little bit more. There we go. There we go. I don't care further than this. I just want the colors to spread out. That's it. So that you can see that you're hitting one of these things. That's it. Why? Oh, blur. I can tell you why it looks funny. Because I went and said when I set this up that I want my red to be red with transparency. I don't want that transparency anymore. I just want a red paddle and a red ball. So there. We're not stroking anything, we're just filling rectangles. I don't think we need to do anything special, so this is fine. So there. We spread out the colors a little bit. We did a little bit of divisions to get like some spread in the color. I just want to do math min I times 2 and then 255, and then we set the fill style to whatever that color evaluates to, and then fill the rectangle. Okay, so I want to smash a property onto this rectangle that says it's alive or not, the same way we did this. I don't know if you remember these, but you can actually just smash properties into objects on the fly, all willy-nilly. I want to smash a property in here that says it is visible, right? So for rkt equals that, rkt dot visible equals true because you're starting this game loop, and then push rkt, right? And then in the draw function we'll just say if not this dot rects dot I dot visible, then just continue the loop. This means jump over. That's what that means. So if it's not visible, then continue the loop. So it should all be visible, and we should be able to see the colors now a little bit more spread out, so we should be able to bounce this thing. Great. So it bounces nicely and it goes straight through, but it's no longer transparent. Oh, that's lovely. I love completely opaque objects. They're so hard to see through. Okay, so now we've got some stuff on the screen. I want to do like move the X like a little bit. I just just want to move the Y. I want the rows a little bit nicer to work with. So J times height plus like 2 pixels. Let's see. No. Is it 2 times J? I think it's 2 times J. Let's just check it. Yep, there. No. I want 1 times J. So it's just plus 1J at any given point. That gives us a 1 pixel gap between these top things. I want the X to also have a 1 pixel gap, right? So plus K RW. How do you now determine the number of rectangles you can fit on the screen? Because as you can see, there's now one less. You first determine the number of rectangles and then subtract the number of rectangles from that, because you're going numrect times 1 pixels. Oh, I think it's just minus 1. Minus 1 rectangle is what you can do. Let's just see if I'm being it. Nope, that's about right. So then it means there's some amount of space left over on the right. So you just divide that by 2 and add it onto the left. So RW left shift 1. No, right shift. What have I done? Plus that. So even though I mangled that keyboard shortcut to not have to do this, I still now ended up in a situation where my half plus that's not right. Not bad. Plus plus. It's such a weird one. This is like the most frustrating editing experience ever. So rectangle width divided by 2 plus the x position of the rectangle plus the actual x position. I don't know why that doesn't work the way I expected it to. What? That works. Huh. So if you... Okay, I'm not gonna do a math lesson here. I'm starting to understand what's happening here. But I'll get it close enough. Just doing okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 rectangles with a width of... just gonna get that with a width of 20 pixels. So that's 300. So that's 3. It's 10. The 10 pixels is huge, like So the X position is 10 pixels plus 0 rectangle width is 0 plus 0 is 0. You're telling me 10 pixels is that massive? It's so weird. It's such a weird one. Like, either I'm losing a rectangle or something is off with my scale. Like, could it really be that big of a jump? My word, it is. So if you do this, what happens? Huh, looks fine. Okay, cool. Whatever. We now have rectangles, and it does the thing. Um, we could also just say. Actually, let's do this. The rectangles don't need to be 10 pixels wide. We can do something smarter. So we can say, what? Oh, color 2 is actually the delete color. So just okay, there we go. So we can say, okay, we know we've got this many pixels and we want to fill it with at least X amount of rectangles. So we can say that we want a gap we should start filling from the left and the right edges. So we pretend we're mirroring on this axis. So we fill in a rectangle, and 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 then in the middle we fill in a rectangle. So we need to work out the center for the center rectangle. So all we need to know is how many rectangles do we want per row. How many are there? 2, 4, 6, 8, 10, 12, 14. 14 is fine. 14 rectangles is good. Okay. So yeah, we're going to do something weird. We're not going to do rectangle with rectangle height. We're going to say numRect x. Right. And then we're going to say numRect y. So the number of rectangles I want in the x-axis are 14, and then along the y-axis is 2, 4, 6, 8. Let's make it 10. Let's just round it up nice. So let's say 10 rectangles. So when we construct this thing, we can say that we know the number of rectangles, right? But we don't know the width. Let's do something to get the width. So for rectangle width equals width divided by numRect x, right? So we do the width divided by the number of rectangles along the x-axis, but it's actually width minus somewhat pixels minus numRect x pixels, right? It's not 3 plus, and then same thing for shoot, that's y. I do what I want. Oh, I did something. I'm assuming I just made a number x. Oh, I made a spelling error because number x, number y. Oh, this becomes this dot. This dot. This dot. This dot. This dot. Let's just check that out. Great, much better, right? Slightly off by like 1 pixel, but so what? Who cares? We distributed that 1 pixel spacing difference in this. Let's just count it. 2, 4, 6, 8, 10, 12, 14 is 2, 4, 6, 8, 10. Okay, perfect. So there's like this 1 pixel little gap on the end. I'm not gonna be like totally crazy about it. I can subtract like 0.5 of a pixel. I don't know. I don't really care. All I care about is that I have a bunch of rectangles, right? So we now have rectangles. We need a game loop. Firstly, we need a score, and we need to determine if we hit any of these rectangles, right? So let's do score first. Score is going to be like the easiest thing ever. So for score equals 0. And I would just throw the score on the screen somewhere. Would draw player, draw ball, draw just as ctx text. Oh, is that how that works? Let's just go see canvas. I don't like the specific view because the canvas reference is massive, right? So you have to click on this thing, but the breadcrumb isn't pretty. Rectangles, paths, transformations, text. There we go. So full text, stroke text, stroke text. Ooh, and the font and the full text. Okay, cool. No doubt. So just set that. Georgia. I want to set this like once. CTX font 20 pixels Georgia, and then CTX full text. This is more something to do with the players. It should go in the player, but I want it to be part of this transformation thing because I want to change the full color. Full color. Full style. That's weird. Not full color. Again, sorry about the mic sounds. It's just weird right now. Okay, so yeah, save, playing field, draw, full style, RG64B96, fill the text, score, plus, what did we call that thing? Score. Oh, okay. Score plus score. The X position, yeah, 10, and the Y is gonna be in a height like -10. I don't know. We'll see what that does. So now we got a score, right? That should be part of. Boom. The score right now is 0, and that text is massive. I want a monospaced font, and I want to fiddle with that size of that text. I'm not happy with it, so I wanted maybe a 10 pixel text, and I want career, and that makes me happy. That pink color is actually quite nice. My wife would like that color. Oh, boom, score 0. It's super blurry. I think I should move it a little bit further left and a little bit further down, so like 4 pixel inner height minus 4 pixel. No, it's, this is interesting. Oh, so the text position seems like it's measured by the baseline. So what that means is that Y position isn't the top left of this thing, it's actually the bottom of this thing. And that's fine. There's nothing wrong with having the Y position at the bottom. Like, it really doesn't make any kind of difference. So now we have a game loop with the scores. So I've seen people implement this where they make the score how many times you bounce on the paddle, right? And they add some variance for how many blocks you break. So let's say a paddle bounce is worth 10 pixels, then a block break would be worth like 100 points or something, right? So let's do that. Like, reward the player for putting the paddle under the ball. It's kind of the whole point of the game. So let's give them a little reward. Just keep them a little bit interested in putting the paddle under the board. Um, uh, this is the check that tells us the ball hit the paddle. So here we can do score plus equals 10. Right. Let's just see if that does what we think it does. I think, yeah, boom, 10. I'm happy with that. I'm super happy with that. So now we have a way to display the score to the player, and we have a way to just to update that score. Oh, that is smooth. I want to play sound, but that's not part of this video. I think we'll stop here for now, given that we've started drawing the playing field and we started keeping track of the score. I think the first thing I want is do I want to put like a start state in? That's like click here to start. No, screw it. What is the loop on this game? It just starts in the middle. That's fine. That's fine. It can just start in the middle. I think we'll save that for now as is. We'll leave it like this. We got a fair amount of code that you guys can go through. I think just this malarkey here, this insanity going on there, you can fiddle with. This is plenty straightforward. You've seen me do the calculation for working this out. Working with arrays, that's fairly straightforward. Just push into an array, pre-allocate. You don't have to pre-allocate, you just say here's an array and you just keep pushing stuff into it. Smacking variables in there, that's easy enough. Loop control mechanisms, so if it's not visible, just jump over this instance. This continue literally just goes back to the beginning of the loop here, this test and increment, right? And then we declare stuff, smack some variables in there, handle the mouse, update the score based on some criteria, and save and restore context, and then draw the player field. I'm happy with that. I'm super happy with that. So we'll stop here today. We've got, I know it's like conceptually not a lot much more than we had in the previous one, but if you think about it, we now have a playing field with like nicely distributed values. I don't want to make these videos too long. I've already spent a fair amount of time just fiddling with this, so I'm happy with this for now. Alright, I'll see you in the next one. Cheers everyone.